Hey there! Today we are diving deep into advanced MongoDB security. We're going to go way beyond just basic passwords and look at three really critical layers of defense: how your servers can trust each other, how you can track every single action inside your database, and of course, how to make your data totally unreadable to anyone who shouldn't have it. Let's get right into it. So here's the big question, right? Your database is up, it's running, everything seems fine. But is it actually secure? Just because it works doesn't mean it's safe. In this explainer, we're going to walk through the exact steps you need to take so you can confidently say, yes, it's secure. First up, internal authentication. Now, this isn't about your users logging in, not yet. This is all about making sure the servers inside your database cluster trust each other. Honestly, this is the absolute foundation of any secure deployment. Think about it for a second. When you've got multiple database servers, those mongo instances, they're all replicating data, they're constantly chattering back and forth. So how does one server know that the other server is a legit part of the team and not some imposter trying to sneak its way in? The answer is something called a key file. The best way to think of it is like a secret password, but it's for your servers. It's just a file with a long, super random string of text, and every single server in your cluster has to have an identical copy. If some new server tries to connect without that exact password, boom, access denied immediately. So how do we actually get this set up? It's really just a four-step process. First, you generate the key file itself. Second, and this is super critical, you lock down its file permissions so only the database process can actually read it. Third, you securely copy that key over to every server. And then finally, you just restart your servers to make this new security feature active. And you can generate this key with a standard tool you probably already have, like openssl. This command right here, for example, just creates a highly random string and saves it to a file. This file, this is now your shared secret. It's your server's password. And just like any critical password, you have to keep it completely under wraps. Okay, so once that key file is in place on all your servers, you simply restart each one with a special flag, -keyfile. You just point it to your new secret file, and from that moment on, MongoDB is going to enforce this internal security check for the entire cluster. No exceptions. And here is a really, really important side effect of doing this. Enabling that key file automatically flips the switch on user authentication. That wide open door is now slammed shut. You can't just connect to the database and start running commands anymore. From now on, every single connection is going to require a valid username and password. Okay, so we're now controlling who can get in. That's a huge step. The logical next step is to track what they're doing once they're inside. And this is exactly where auditing comes into play. Right, so with authentication turned on, we know the user behind every single action. But how do we create a permanent, unchangeable log of everything they do? Something we can go back to for security reviews, for compliance checks, or, just to figure out what went wrong last Tuesday. MongoDB's auditing feature lets you log a massive range of events. We're talking about every user login and logout, every single create, read, update, and delete operation, all the administrative actions like creating a new user. You can even see when someone creates an index. And crucially, it doesn't just log the successes, it also logs every single failed attempt to access data. Now, MongoDB gives you a couple of options for where to send all these audit logs. You can stream them to syslog, which is perfect if you want to plug this into a bigger real-time security monitoring system that watches your entire company. Or you can write them out to a JSON file on disk. This is ideal for creating that long-term, super detailed archive you might need for forensic analysis or to pass a compliance audit. Just one thing to keep in mind, auditing absolutely everything can create enormous log files. So to manage that, you can use audit filters to be a lot more selective. For instance, you could tell MongoDB to only log administrative commands, or maybe to log every single action but only for one specific high-privileged user. This really helps you cut through the noise and just focus on what's most critical. All right, we've secured our servers from each other and we're tracking all the user activity. Now it's time for the final, and you could argue, the most critical layer of defense, encrypting the data itself. Because if all else fails and an attacker somehow gets their hands on your data files, encryption is what makes that data completely useless to them. It's really important to think about encryption in two different layers. First, you've got encryption in motion, using TLS or SSL. This scrambles your data as it travels across the network, so no one can eavesdrop on it. Then you've got encryption at rest, also called transparent data encryption. This protects the physical files sitting on the hard drive, so even if someone steals the entire drive, the data is just gibberish. You really need both. The good news here is that turning on encryption at rest is surprisingly simple. Just like with our internal authentication, the process starts by generating a secure key file. After that, you just restart your database server with a couple of new flags that point to that encryption key. That's it. And here is the command that makes all the magic happen. That -enable encryption flag just turns the feature on, and the -encryption key file flag tells MongoDB where to find the key it needs to encrypt and decrypt your data files on the fly. MongoDB just handles the rest in the background, completely transparently. So let's just quickly recap the 3 big takeaways. 1. Use key files to make absolutely sure your database servers trust each other. 2. Turn on auditing to create a complete log of who did what and when. And 3. Encrypt your data everywhere, both in motion as it travels over the network and at rest when it's sitting on the hard drive. If you do these 3 things, you've built a really formidable defense for your database. But, a secure database is only one piece of the puzzle. It kind of leads to the next big question. How are you securing the application that actually connects to it? Because at the end of the day, a chain is only as strong as its weakest link. And that wraps up our look at advanced MongoDB security. If this helped you out, a like, a share, or a subscription is always, always appreciated. We'll be back with more deep dives very soon. Thanks for watching.